Hi and welcome to video 2 on index laws. So in this video we're going to talk about negative indices. We'll learn and revise the negative index laws, and I'm going to show you as best I can why that's the case. And we're going to apply this to a range of problems. Probably not too many because there are plenty of examples around there, but I'll take you through 2 or 3 of these examples. And we will rely on our basic index laws. So if you had a look at the last video, I outlined 6 basic index laws, and they're arbitrarily numbered, and I might refer to those numbers. So if you have a copy of those down, I'll obviously write down the index law as well, but I might name them by number as well. But it is, of course, my numbering. So if you see or talk to somebody else, they may have a different numbering. So let's talk about this negative index law, which I'm going to call index law number 7. To stick with my numbering system, and I'll write here negative indices. So in this law, a to the power of negative 1 is equal to 1 over a. That's the really simple version of it. The more complex version of it is a to the power of negative n is equal to 1 over a to the n. So if we're dealing with a negative indice, then a negative indice is the reciprocal. So that's a really good word to know and be able to use. It's basically where we flip the fraction over. The reciprocal of a to the positive index. So if you have a to the power of negative 3, then it becomes 1 over a to the power of 3. Now let's have a quick talk about why. Why is this the case? And let's just refresh our memories on list of indices. So I'm going to start high. I'm going to start with 3 to the power of 4. And if you do that in a calculator, you'll get 81. And then I'm going to write down a few more of these. 3 cubed. Okay, so we've got our first 5 indices that we know of for power 3. Now I really want to bring about this little pattern that's occurring here. We know that when we move up the list, we multiply by 3. That's what an index does. And that means that if we move down the list, we divide by 3. So naturally, this leads to the fact that if we are going to define negative indices, and they are just human definitions, well, the definition would rely on this moving down the list. So 3 to the power of negative 1 is equal to 1 divided by 3, which can be written as 1/3. And of course, we can take it further and keep on dividing by 3. 1 over 9. 1/3 divided by 3 is 1 over 9, which just happens to equal 1 over 3 squared. And 3 to the power of negative 3, 1 over 27, which just happens to equal 1 over 3 cubed. And so you see that pattern occurring there in pink, that we are simply dividing by 3 each time we go down. So let's have a look at some examples. Example 1. Let's evaluate 3 to the power of negative 4. Notice that I've gone down to 3 to the power of negative 3 there, so let's do 3 to the power of negative 4. And we can use this negative indice law to write this down as 1 over 3 to the power of 4. And ideally, we can do this without a calculator. So you should be thinking in the first instance, can I do this without a calculator? And 3 to the power of 4 is 3 times 3 times 3 times 3 is 81, so it's 1 over 81. So that's evaluating. Evaluate will typically mean get a numerical answer for. Write this down as a number. Whereas our second example, I'm going to ask for a simplification. And simplifying might rely on you just getting the algebraic terms and bringing them into a simpler form. But it also might rely on you doing it with numbers as well. So if I have this question, 2 to the power of 5 times 2 to the power of negative 3 cubed times 2 squared, I can simplify this down to be an index form. Now you may be asked to simplify without fractions, in which case you'll need to use negative indices. And you may be asked to simplify using positive indices only, in which case you'd have to reciprocate the negative indices so that they go into the denominator and that they are positive. So you have to read the question and be able to follow the guidelines you're given. So this is 2 to the power of 5 times, now I'm going to use that index law 5 from video 1, where if we expand these brackets, we have power over power, we multiply the powers, so that's 2 to the power of negative 9 times by 2 squared. And so let me just remind you of that one, that is a to the power of m to the power of n is equal to a to the power of mn. And of course, if we have a to the power of m times a to the power of n, this is equal to a to the power of m plus n. I'm going to use that in my second line. 2 to the power of 5 plus negative 9 plus 2. And that, of course, is equal to 2 to the power of 5 plus 2 is 7, minus 9, that's negative 2. And this would be my answer for a simplification case where I haven't been asked to do anything in particular. If I'm asked to use positive indices, then I'll need to write this down as 1 over 2 squared. And if I'm asked to evaluate, then I'll need to write this down as 1/4. So you have those options there. And that's example 2. Now I'm going to ramp it up a little bit for example 3. It will be algebraic and it will be a little bit tougher. So example 3 looks like this. 10a cubed b to the negative 2 over 5a to the negative 1 b squared, all to the power of negative 1. So there's some negative indices in there, there's some positive indices in there, there's some numbers in there. And it's starting to get a little bit tougher to simplify these. So there are two options here. First of all, I can do my simplification on the inside of the bracket first. I can combine the 10 and the 5 by doing 10 divided by 5, the a to the power of 3 and a to the power of negative 1 because they're the same base by subtracting, and the b's by subtracting as well. I can set that up. But I really want to point out to you the fact that that negative 1 on the outside of the brackets, this guy here, is just a reciprocal function. It just reciprocates. If it was negative 2, then the square component would remain, but it would still reciprocate. So I can write this down as 5a to the negative 1 b to the squared over 10a cubed b to the negative 2. So all I've done is I've flipped that fraction over, I've reciprocated it. That's what that negative 1 does. If it was a negative 2, I would still have a squared on the outside and I'd have to deal with that. So now I'm going to simplify this. First of all, 5 divided by 10 gives me a 1 on top and a 2 on the bottom, so that's a half. And then, of course, I get a to the power of negative 1 divided by a to the power of 3 is a to the power of negative 1 minus 3. And b to the power of 2 minus negative 2. So remember, we subtract, and because the number is negative for b, then it's minus a negative, which will actually end up being a plus. So I end up with 1 over 2, a to the power of negative 4, b to the power of 4. Whilst that is a complete answer now, that's as simple as it goes, I'm going to write this using positive indices only. So I get b to the power of 4 stays on top, a to the power of 4 on the bottom because I've used that negative indice law on a to the power of negative 4. And the half means that there is a 2 in my denominator. And that's the simplest version I can do. So that is negative indices in a sub 10-minute video. If you have any questions, obviously you're welcome to ask. Otherwise, have a great day.